السلام عليكم. في هذا الفيديو راح أشرح محاضرة الأسبوع الثالث من منهج Math111، المنهج المقرر على طلاب وطالبات السنه التحضيريه بجامعه الامام عبدالرحمن بن فيصل. راح نتكلم بداية عن section 1.3 اللي هو integers exponents. أول شيء راح أتكلم عنه بداية what is a to the power n. a to the power n is a time itself in times, where a is a real number and n is a natural number. Okay, so the expression a to the power n ويقرأ أو read as a raised to the nth power، أو نقول a to the power n. a is the base اللي هو الأساس، n is the exponent أو الباور أو الأس. Okay, so a to the power 1 equal a. So anything to the power 1 is actually a, and we usually don't write the power if it's 1. The negative integer exponent, so when the exponent is negative, this means that the number is upside down. Yani we can put the number upside down and take the negative sign. So for example, if I have 2 to the power negative 3, I can write that as 1 over 2 to the power 3. If it's negative 2 to the power negative 3, the negative has nothing to do with the power, so I will put it as it is. Okay, so negative هذه ما لها علاقة بالpower, so راح أنزلها. Okay, so let's take some examples. For example, here we have 3 to the power negative 1. So since here the denominator is 1, I will flip the fraction. يعني negative معناتها إني أنا أقلب الفراكشن. So flip the fraction, so it would be 1 over 3. طبعا I can say that 3 to the power 1, but I said before we don't have to write the power if it's 1. So this would be 1 over 3. Okay, for part B, same things. The negative, I will put the negative because it has nothing to do with the power. Then I will flip the fraction. The denominator here equal 1. So it would, the 3 to the power 2 would be in the denominator, and in the numerator I'll put 1. So the answer is negative 1 over 3 to the power 2. In C, we have same thing. So 3 to the power negative 3, I'll put it up 3 to the power 3 without negative in the power. And in this one, the negative here is included to the power. Okay, so I have to be careful with this one. I will flip the fraction. So I'll put the number, which is negative 3 to the power 4, up without negative. Then I will simplify this value. Negative to the power 4, since 4 is even number, so the negative will be cancelled, and I'll left with the 3 to the power 4. Of course, here I can find out what is the 3 to the power 4 is 81, and 3 to the power 3 is 27, and 3 to the power 2 is 9. Okay, we have here try and check. Negative 2 times 4 to the power negative 2. So I can write this as negative 2. I'll put negative 2 as it is. Then 4, since it has negative in the power, so I'll put it in the denominator, 4 to the power 2. Okay, you have two ways here to simplify this fraction. You can just find out 4 to the power 2, which is 16, and write 2, negative 2 over 16, and then simplify. 16 divided by 2 is 8, so it would be negative 1 over 8. Or you can write 4 in a power form, so it would be negative 2 over, since 4 is 2 to the power 2, so this would be 2 to the power 2 all to the power 2. Then this would be negative 2 over 2 to the power 4, and now I can cancel one of these two with one of the 2 in the denominator with the numerator, so I'm left with negative 1 over 2 to the power 3, and 2 to the power 3 is 8, so negative 1 over 8. Okay, now let's see part B. I have negative 5 to the power negative 2, so I will move this part up with negative 5 to the power 2. Okay, so I have Okay, so in this case, I would have 3 times negative 5 to the power 2. And you know that this negative, since here we have even, so this negative would be cancelled. So I'm left with the 3 times 5 to the power 2. And you know 5 to the power 2 is 25. So 3 times 25. And 3 times 25 is 75. Okay, part C. So same things here. I will move negative 5 up. So this would be 3 times negative 5 to the power 3 without negative in the power. So since here negative and this is odd, so the negative will stay. So I have 3 times negative 5 to the power 3 is 125. So I will times those numbers together. So I have negative. Then 3 times 5 is 15. 3 times 2 is 6. And 1 here is 7. Then 3 times 1 equal 3. Okay, the last one, we have negative. So I'll put this negative as it is. Then I have 3 also. I'll put it. Then in the denominator, I will move the numbers to the numerator and cancel the negative in the power. So negative 3 to the power 3. Now since here I have negative, but here I have odd, so the negative here will stay, okay? And so this would be negative 3 times negative 3 to the power, so times, let me write it this way. So this would be negative 3 times negative 3 to the power 3. So negative 3 times negative 27. So negative times negative would be positive, and 3 times 27 is 81. So the answer is 81. The integer exponents also, we have here 0 exponent. What does it mean by 0 exponent? It means a raised to the power 0, and in this case, it would be 1. Well, no matter what is a, anything to the power 0 equal 1. Even million to the power 0, the answer would be 1. So 3 to the power 0 would be 1. Negative 3 to the power 0, so same things here, but negative, I will put the negative as it is. Then I will find 3 to the power 0, which is 1. So it would be negative 1. You have to be careful with the negative if it's included with the 0, with the power or not. So this has nothing to do with 0. So the negative will stay to the end of the answer. Okay, 1 over 3 to the power 0. 3 to the power 0 is 1, so 1 over 1, which is 1. And here, negative 3 to the power 0, so it is a number, negative 3 to a power 0, so it would be 1. Okay? And 1 over 1 equal 1. So this is the difference. You have to be careful of the difference between 3 to the power 0, negative 3 to the power 0, or negative 3 to the power 0. In this case, the negative would stay, then I find 3 to the power 0, which is 1. But in this case, hold the number here, the whole number raised to the power 0, so it is 1. So this does not equal this. Integer exponents. Here we have some laws of the exponents. How to deal with the exponents sometimes if they have. Okay, we have some rules when you deal with the expressions, with the exponential expressions. The rules can be applied if we have the same base. Okay, we have the same base, and the operation between those two numbers is times. Or we have the same base, okay, and the operation is division. Or if we have the numbers is raised to the power and all to the other power. Or like here, if we have two numbers, two different numbers, then all to the power n. or we have two different numbers, the division of two different numbers, then all to the power n. So only in those cases we can use the rule. The first rule is that if we have the same base and each one has different powers, and we have the operation in between those two numbers are times. So all what you have to do is just to put the base as it is and then add the powers. Okay, let's see, for example, I have 2 to the power 2 times 2 to the power 3. So 2 to the power 2 is 2 times 2, and 2 to the power 3 is 2 times 2 times 2. So in all, you can see that 2 is repeated 5 times, so I can write that as 2 to the power 5. So looking back to the exponent here and the exponent here, you can see that we add the exponent. So if you have a common base and if the powers are different, we can just put the base as it is and then add the power. Also here, if we have a common base in the quotient, so all what you have to do is to minus the powers. Okay, we minus the powers. And also you can see if I have 2 to the power 2 over 2 to the power 3. So the reason that we have the power is the difference of the powers of the result is the difference of the powers, because here 2 times 2 and this one is 2 times 2 times 2. So I will cancel this one with this one and this one with this one. I will left with 1 over 2, which is 2 to the power negative 1. And you can see that negative 1 is 2 minus 3. So all what you have to do is to minus the powers. Okay, now rule number 3, you have a to the power n, then all to the power m. Okay, so same things. If I have 2 to the power 2, all to the power 3, this means 2 to the power 2 times 2 to the power 2 times 2 to the power 2. 3 times. Then each one of those is repeated 2 times. So 2 times 2, and here 2 times 2, and this one is 2 times 2. So in all, I can see that I repeat 2 6 times. So you can see that 2 times 3 is 6. Okay, for rule number 4, I have a times b all to the power n. So in this case, I can just distribute the power to a and to b, and also in the division, I can distribute the power to a and to b. Okay. Now we have an example here. As you can see, the question here to simplify the expression by using the properties of exponent, and then we write our exponent with a positive exponent only. Okay, positive exponent only. So if you have a negative exponent, you have to change the location of the number. If it's a negative exponent and it's in the numerator, we put it in the denominator, and the vice versa. So let's start with this question. We have 20 times x to the power 3 times y to the power 4 over negative 4xy squared. So the best way to do that is to put the numbers above it, in the numerator, above the numbers in the denominator, and so on. So as you can see here, 20 over negative 4, and I put the x's together and the y's together. Now it's easier for us to simplify. Since 20 is 5 times 4, I would cancel this 4 with this 4. I will left with 5 and negative, so negative 5. And here x to the power 3 with over x is x to the power 2, or I can just minus the powers, 3 minus 1. And here also y to the power 4 minus 2. I subtract the power since I have division. So the answer is negative 5, and here x to the power 2, y to the power 2. Okay, for this part, First, I have to distribute the power. So I will distribute the power to A and B and C, and also this power. So, and power to the power means I will times the powers together. So here A to the power 2, this would be A to the power 2, then B to the power 3 times 2, then C to the power 2 times 2. Okay, so the same things I will do in the denominator, A to the power 5 times 2, then B to the power 2 times 2, then C to the power 3 times 2. Now I just do the times, so I will get A to the power 2, B to the power 6, C to the power 4, and same things in the denominator. So all what I have to do here is to subtract the power, but the best things is to do it faster is to subtract up if it's if the power up is more. If the power up is more, you subtract it up, and if the power down more, you subtract down. Okay, for example here, since 6 is larger, since 6 is larger than 4, so I do the subtraction up. And here, since 6 is more than 4, I do the subtraction down, because I don't want to get a negative exponent. Then I have to do the, I have to change its place to get rid of the negative sign in the power. So the same things in the last number. Here I have 2 and here I have 10. So 10 is more, so I'll do the subtraction down. So the answer would be B to the power 2 times A to the power 8, C to the power 2. So let's do this part. You simplify the following expression using the rules of exponent, then write your answer in the positive exponent only. So first I will distribute the powers. So this would be 5 to the power 3 times x to the power 12 times y to the power 9. So when I distribute, I times with the powers directly. In the denominator, 15 to the power 2, x to the power 2, y to the power 10. Okay? Okay, now I can simplify 5 to the power 3. And 15, I can write 15 as 5 times 3. And since here I have a square, so I should put the square in both number. So this would be square and square. Okay, now for x, since 12 is bigger than 2, so I will subtract up. So this would be x to the power 12 minus 2. And for y, I will subtract down, so 10 minus 9. Now let's simplify the numbers here. 5 to the power 3, I will simplify 5 to the power 3 with 5 to the power 2. So the answer would be 5 in the numerator. And here x to the power 12 minus 2, 10. And then I have 3 to the power 2, which is 9. Then y to the power 10 minus 9 is 1. Okay? Okay, second one, I have negative 2. And 6, I can write 6 as a 3 times 2. Then x, I will subtract x down because it is larger. Okay, so this would be x to the power 5 minus 3. And then y, I will subtract y up, so it would be y to the power 5 minus 3. So x to the power 5 minus 3, and here y 5 minus 3. So the answer, this 2 would cancel this 2. I will left here with a negative, and below here 3, and then y to the power 2, and x to the power 2. Okay. Okay. Now we have the scientific notations. In the scientific notation, we write the number as 8 times 10 to the power n. Okay, in this form. This form, we call this form scientific notation. A is between 1 and 10. Okay, and n is an integer. N is an integer, okay? So imagine here you have 3.14 times 10 to the power 3. This is an example of scientific notation, but 31.4 times 10 to the power 2 is not a scientific notation because the number here should be in between 1 and 10. So either 1, 2, 3, 4, 5, 6, 7, 8, and 9. That's it. Okay, so we should put it in that form, and this form, we call this form is a scientific notation. So here you have some powers of 10. So 10 to the power negative 4, it means 0.0001, which means 4 digit. We have 4 digit after the decimal. Okay, and 10 to the power negative 3, I have 3 digits after the decimal. 10 to the power negative 2, I have 2 digits after the decimals, and 10 to the power negative 1, I have only 1 digit. And of course, 10 to the power 0 equal 1. 10 to the power 1 equal 10 or 1 0. 10 to the power 2 equal 100 or 2 0. And 10 to the power 3 is 1000, and so on. So let's see here, how can we write each number in a scientific notation? As we said, since we have to have the decimals in this position, and the decimal usually of any numbers is located to the very end right of the numbers. So it's located here, and I have to move it from this side to this side. So count how many digits you have to move the decimal. 1, 2, 3, 4, 5, 6, 7, and 8. So 8 digits you have to move the decimals. And since the numbers here is more than 1, so the power would be 8. Or since you moved the digits to the left, so you have to write the digits as 10 to the power 8. And then you put the numbers, okay, you put this numbers, which is 2.95. If you have more numbers other than 0, you have to write them down. Okay, for example, if the numbers is 2956, so you have to write 6 over here, but the 0 you don't have to write zeros because we have million zeros after 5 here. Okay. For B, I'm gonna move this decimal from this place to the very end sorry. So I'm gonna move this decimals from this place to be here. Okay. So I'm going to count here 1, 2, 3, 4, 5, 6, 7, 8, 9. So I move it 9, and since I'm going to move it from the right to the left, from the left to the right. So I'm gonna just write the power in the negative 9. Okay, so it would be 1.05 times 10 to the power negative 9. Okay, let's check this one. Write each number in a scientific notation. So same things. If it's big number, I'll write times 10 to the power, to the positive power. So from here, I will move to this side. So 1, 2, 3, 4, 5, 6. Then I write here 6.4. And this one, so I'm going to move the digits 2 here. So it would be 2 times 10 to the power negative, because originally it is less than 1. So 1, 2, 3, 4, 5, 6, 7, 8, and 9. Rewrite the following numbers in a decimals form Okay, so it is the reverse way. So we're going to return it back to the decimals form. So this one means I will move the decimals to the right 4 digits. I will move the decimals to the right 4 digits. And here I will move the decimals to the left 5 digits. Okay, so 2, then 0, this is 1, this is 2, this is a 3, this is 4. So if you don't have any numbers, you can just add zeros. And for this, for B, 5, 0, 1. So I'm going to move the digits from here to the left. So 1. So I will not try, I will cancel this one. So 1, then 2, then 3, 4, 5. Then I put the decimals and I put 0 to clarify the decimals. So let's try this one. Here, times 10 to the power 6. So I'm going to move it to the right 6 digits. So this is 1. So 1, 2, 3, 4, 5, 6. This is the answer. And for part B, I have 4, 1. So I'm going to move from here to the left 6 digits. So 1, 2, 3. This is 1, 2, 3, 4, 5, 6. Then I put the decimals. Of course, I will remove this one. Okay. Okay, we have also here in chapter 1, we have section 1.4. We will talk about basic operations in polynomials. The basic operations in polynomial, first of all, let's learn what is the polynomials. The first kind of the polynomials are the monomials. Okay, this is the first types of the polynomials. What is the monomial? Is a real number or a product of real numbers and one or more variables with a non-negative integer exponent. The number is called the coefficient of the monomial. This is such an examples of monomial like this one and this one and this one and this one. This is all examples of monomial. So the monomial, the first one, has a variable and has a numbers. These are the variables. We have x, y, and z, and the numbers, which is negative 1 over 2, we call that number as a coefficient. يعني المعامل. Okay? And the second one, the variables of the second one is y and v, and the coefficient is negative 1. And the third one, a, b, c, are the variables, and the coefficient equal 1. So why the coefficient here is 1? Because there is nothing. It means we times this with 1, okay? We times this with 1. And for this one, we don't have variables, so it looks like the variables here, whatever is his, for example, x or a, is raised to the power 0. That's why it equal 1, okay? So there is nothing, which means it times with 1. And what makes the variable 1 is when it's raised to the 0 power. So we call this kind of monomial is a constant monomial. Constant يعني ثابت. Constant monomials. And the coefficient here equal 15. Okay, what is the degree of the monomial? So the degree of the monomial is the sum of the exponents of the variables. So let's, for example, in this one, we have here power 2 and here power 1 and here power 1. So the degree is 2 plus 1 plus 1, which is 4. And the same things here, we have to add 2 with 3, and it will give us 5. And here we will add all the exponent together, 1 plus 1 plus 5, which is 7. And the degree of the 15, Since, as I said before, the variables here equal 1, so it's raised to the power 0. So the power of the exponent is 0, so the degree is 0. A polynomial is a monomial or sum of monomials. Each monomial in that sum is a term of the polynomial. So polynomial يعني كثيرة حدود، مش يعني monomial حد واحد. البولينوميال أكثر من حد. So the polynomial contain more than one monomials. Okay, more than one monomial. And each one of those we call terms, يعني حد. Okay. A polynomial with 2 terms we call it binomial. With 3 terms it is trinomial. مثل ما انتم عارفين مثل bicycle يعني دراجة بعجلتين أو tricycle دراجة ب3 عجلات. So دائما الباي تشير إلى 2. الباي تشير إلى 2 والتراي تشير إلى 3. So that's why binomial has 2 terms and trinomial has 3 terms. This is such an examples of monomial and binomial and trinomial. As you can see, here you have 3 terms. كيف أعرف إنهم 3 terms? In between each terms we have a plus or minus. Okay, so this is one term, then the operation, then another term. Here I have only one term, only one term, only one term. But here I have 2, here I have 2, here 3, and in between there is a plus. Okay, let's see here the degree of a polynomial. So since I have more than one term, the degree would be the highest degree. Okay, so the terms that has a highest degree. So I'm going to check all the degree of the terms, then I will take the highest one. Any non-zero real number is a polynomial with degree 7. Okay, I can call any non-zero real numbers as a polynomial with degree 0 because as we said, the variables that times with that number raised to the power 0. That's why it does not appear, okay, because it's equal 1, and we usually do not write the numbers times 1. The number 0 is a polynomial with no defined degree. So if I have 0, there is nothing here to times it with, so it would be the degree of that one is undefined, and we call that polynomial 0 polynomial. Okay, let's see here we have a polynomial. We want to know what are the terms of this polynomial. So this is the first one, this is the second one, and be careful to take each terms with its sign. This is the third one, and here fourth one, and fifth one, and sixth one. So we have 6 terms in this polynomial. In each polynomials, we can find the coefficient, which is the numbers or the constant. Okay, so for the first one, you can see there is nothing, but actually it times with 1, so the number or the coefficient is 1. And here is 15, this is the coefficient. Here is negative, so it's negative 1. And here is 5, and this one is 3, and this one is 9. Now the degree, obviously we just add the exponent of the variables. So here 3 plus 1, which is 4. Here 1 plus 3 plus 4 equal 8. Here 1 plus 1 equal 2. Here 1 plus 1 equal 2. And here 2. And here nothing, so it would be 0. Now the degree of the polynomial is it's the highest degree, and you can see that the highest degree of this all is 8. So that's why the degree is 8. So let's try and check this examples, the same things. I will first write the terms. So the first one is x to the power 3. The second one is negative xyz. Then here negative t. Then this 2yt, 3x squared yzts. What is the coefficient? For the first one is 1. And the second one negative 1. And here is negative 1. Here 2. And here is 3. Okay, what is the degree? The degree of this one is 3. The degree of this one is 1 plus 1 plus 1, which equal 3. And for this one is 1. And the degree for this one is 1 plus 1, which is 2. And for this one is 2 plus 1 plus 1 plus 1 plus 1, which is 6. So now to find out the degree of the polynomial, we have to pick the largest degree, which is 6. So the degree is 6. Okay. Now, how can we add to polynomial or subtract to polynomial? In order to do that, you have to have similar terms. So similar terms or like terms of a polynomial are either constant or terms having the same variables with the same exponent. So they have to have the same variables exactly, and the variables have the same exponent also. So to combine or to add or to minus like terms in the polynomial, we just add or subtract the coefficient and put the variables as it is or as they are. Okay, so let's see here. We have x squared y, and here also we have x squared y. So that's why we have 2 of x squared y and 5 of x squared y. So 2 plus 5 equals 7 of x squared y. Okay, and here I have x squared y also. So 2 minus 5, then x squared y, which is negative 3x squared y. So it looks like you just take x squared y as a common factor, then you subtract or add the numbers. But for this polynomials, you can't add those terms because they are different, since x squared y in the first one does not equal xy squared. Okay, they have different exponents, so they are different terms, so we can't combine them. Let's see here, we have 4xy x squared y plus xy squared minus y squared plus 3x squared y plus 1. So I'm going to add the similar terms together. So this terms with this terms, I will add them together. Okay, and then this one has no other terms to add with, and also this one and this one. Okay, so I will put those in the question. Okay, then I will just add these two together. I have 4 of this and 3 of this, so they would be 7. 7x squared y, and then I will put those as they are. Okay, for part B, the same things. I will just add the terms, the like terms together. So this one, x to the power 3y. I have 3 terms, x to the power 3, x to the power 3, and here x to the power 3y. So I would add those together, and then I put these terms as it is to the, okay. So let's add those together. Here I have 2, here I have -1, here I have -3. So the answer would be -2 x3y minus xy. Okay, a polynomial in one variable. If we want to talk about the polynomial in one variable, the standard form of this kind of polynomial is an x to the power n plus an minus 1 x to the power n minus 1, and so on until a1 x to the power 1 plus a0 times x to the power 0, which is 1, and we don't write that one. The a's here are the real numbers, okay, and an does not equal 0, and n is the non-negative integers. The degree of this polynomial is n because it is the highest degree, and the leading coefficient is an. What does it mean, leading coefficient? Is the coefficient of the highest of the variable that has the highest degree. Okay, يعني معامل المتغير ذو الأس الأكبر. And the constant constant term هو الحد الثابت اللي هو A0, the last one. Okay, let's see this one. Now I have this polynomial. It's not written in the standard form. We have to write it in the standard form. So in order to write it in the standard form, I will start with the variable with highest degree and then to the lowest degree. And also I need to check if I have two variables that can be combined. I will add them together. For example, here 3x and here 8x. So 11x, and then I would start with the power 7, then power 2, then power 1, then power 0. So the degree here obviously would be power 7, and the leading coefficient, okay, which is the number beside the highest degree, which is -1. Okay, the constant terms الحد الثابت, which is -1. The coefficient of x to the power 0, x to the power 4 is 0. Since we don't have here x to the power 4, actually we don't have x to the power 6 also, or x to the power 5, and x to the power 4, x to the power 3, and yes. So all those x's are not in the polynomial, since the coefficient of them are 0. Okay. So let's see this one, same things, the standard form. So I will start with this power, then power 4, then power 3, then power 1. Okay, so this is the standard form, and be careful, if you have any two terms has the same power and same variables, we can add them together. Okay, the degree here, the degree is this. The degree is the highest degree, which is 5, and the leading coefficient equal 1, which is the coefficient of x to the power 5. So the coefficient of x to the power 5 here is 1, and this is the degree. And the constant terms الحد الثابت, there is nothing, so it would be 0. And the coefficient of x to the power 4, here I have x to the power 4, and the coefficient is -5. Be careful to take the number with the sign. So this would be -5. Write each of the following polynomials in the standard form, then indicate the degree, the leading coefficient, the constant terms, and the coefficient of x to the power 4. Let's see part A. -x to the power 7 plus 8x plus x to the power 10 plus 3x minus 1. What is the standard form of this polynomial? So we're going to start with the highest power, which is x to the power 10. Then the negative x to the power 7. Then we have two terms with x. So we're going to combine them. We have plus 8 plus 3 is 11x. Then the constant, which is -1. The degree of this polynomial, the highest degree of the terms, which is 10. And here the leading coefficient, which is the coefficient of x to the power 10. Since there is nothing here, it means it would be 1. And then the constant terms, which is the constant here, which is -1. And the coefficient of x to the power 4, here we don't have x to the power 4, so the coefficient would be 0. Okay, so this is A. For B, we have, as you can see, we have here x to the power 3, and here -x to the power 3. And also we have power 4. So first we're going to start with the terms with x to the power 4, so -5x to the power 4. Then we're going to combine this two. So x to the power 3 minus x to the power 3 is 0, so this would be cancelled. Then we will write plus 2x. Okay, what is the degree? The degree is the highest power here, which is 4. What is the leading coefficient? The leading coefficient is the numbers beside the x to the power 4, which is negative 5. Then the constant, here there is nothing, there is no constant, there is no number stand by itself, so the constant would be 0. And the coefficient of x to the power 4, we can see this is the coefficient of x to the power 4 again, so it would be negative 5. Operations on polynomials like adding, subtracting, multiplying two polynomials, or dividing. Let's see first adding or subtracting polynomials. We have here these examples. We have this polynomial, then plus this polynomial, then plus this polynomial. Since we have addition, there is no meaning for keeping those parentheses. So the first things we will do here is to get rid of those parentheses. So we will write the polynomials without parentheses like this. Okay. The second thing is to combine the similar terms together. So any terms with x to the power 4, where, for example, here we have x to the power 4, only one term, and we have two terms in x to the power 3, and here we have two terms in x to the power 2, and one term in x to the power 1, and this is for the constant. Step 3, we will add those similar terms together. So as you can see, here we have x to the power 3 plus 3x to the power 3, which is 4x to the power 3. So all you have to do is to add the numbers and put the variable as it is. Here we have negative 5 and minus 1, which is negative 6. Then we put x to the power 2. And of course, this we will put it as it is. Then we will add the numbers. 6 plus 1 plus 10 equal plus 17. Okay, this is another examples. We have in subtracting. We have the example is subtract this polynomial from this polynomial. So we'll write this one, then we will subtract it from the first one. Okay, so same things. First things, we will trying to remove the parentheses. We will trying to remove the parentheses, but since here we have negative, so we have this to distribute the negative, okay, to all the terms inside the parentheses. Distributing the negative means we will change the sign of the terms. If it's negative, would be positive. It's positive, it would be negative. So as you can see here, we just put the first polynomial as it is, and then we change the signs of the second polynomial. So here we have negative, it would be positive. This positive, it would be negative. This positive, it would be negative. Now we will combine the similar terms together. So we have here x to the power 3 with this x to the power 3. So 1 plus 1/3, it would be 4/3 x to the power 3. Okay, then we have x to the power 2 with this x to the power 2. So we have 1 minus 1 over 2, it would be 1 over 2 x to the power 2. Okay, as you can see also, we have only one terms in x, so we will put it as it is. Then we will add this number with this number, so 1 minus 1 equals 0. So we will not put any numbers here.